Hello everyone, hope you're all doing well. Today we'll work on solving the third degree equation, that is the cubic equation, although the methodology I'll show you works with the fourth degree, the fifth degree equation and so on. So let's get started. What we need is two theorems. First of all, we need the factor theorem, which states that a polynomial f of x has a factor x minus k if and only if f of k equals to 0. Let me write that down. Factor theorem, which states that, as I said, that the polynomial f of x has a factor, let's say x minus k, if and only if and only if f of k equals to 0. And the other theorem we will need is the integral root theorem. Integral root theorem, which states that for a polynomial f of x with integer coefficients, if k that is not 0 is a root of the equation f of x equals to 0, then this k is a divisor of the constant term. I say that again. For a polynomial with integer coefficients, if a number k not 0 is a root of the equation, if k different than 0 is a root of f of x equals to 0, then this k is a divisor of the constant term of f of x. So, let's see how this works through an example and how this helps us solve the equation f of x equals to 0. Let me erase those. You can always pause and write down what I have written before I erased. So, let's see this through an example. We have this exercise. Solve the equation f of x equals minus x on the third power plus 9x squared minus 26x plus 24. And the exercise requires from us to solve the equation f of x equals to 0, or in other words, find the roots, or find the roots or the solutions of the equation. Roots means solutions, okay? So, what do we do first? First, we identify which one is the constant term. The constant term is this one, the blue one, the 24. So, what do we need to do first is to identify which numbers divide 24. Can you see what are those numbers? Pause the video and think of it for a second. So, the divisors of 24 are +1 and -1, +2 and -2. What else? Is 3 a divisor? 24 divided by 3? Yes, it is. So, +3 and -3. Be very careful we get both numbers. With +3, -3, +1, -1. We don't pick only one, we pick its -2. What else? Is 4? 4 times 6 is 24. So it's +4, -4, +6, -6, +8, -8, +12, -12, and +24, -24. This is the first step we need to do, to identify which numbers are the divisors of 24. I believe I haven't forgotten anyone, and that's all of them. So, here is where it gets a little bit tricky. We need to pick them one by one and check this. For example, we will pick the +1 first. We'll check f of 1. F of 1 is -1 on the third power, plus 9 times 1 squared, minus 26 times 1, plus 24. And this one is -1, plus 9, minus 26, plus 24, which equals 9 minus 1 is 8, minus 26 plus 24 is -2, which is 6. We want this to be 0. This is not 0, so 1 is not the number we are looking for. We delete this. You will ask me now, hey Ted, are we going to pick them one by one? That is, after +1, are we going to pick -1, then +2, then -2, etc., etc.? Well, there is a strategy behind this, how we should be working here. What I do is I pick the positive numbers first, which means that after 1, I will pick this one. So I intend to find f of 2, which is -2 on the third power, plus 9 times 2 squared, minus 26 times 2, plus 24, which equals to -8, plus 2 squared is 4, 4 times 9 is 36, minus 52 plus 24 equals to -8 minus 52 is -60. -60. 36 plus 24 is 60. -60 plus 60 equals 0. So, what does this mean? That f of 2, this means that f of 2 equals to 0. So I found that f of 2 equals 0, meaning that x1 equals 2 is a root. I've found one root or a solution. But what I care most about here is that x minus 2 divides this polynomial, which means it divides this polynomial and it leaves a remainder of 0. So, let's see what we do next. What we are going to do next is to pick this polynomial here, the black one. Let me, excuse me, copy this and change page. And we are going to do the division, the polynomial division by x minus 2. And we know from the beginning that down here there will be 0. And there will be something here, a quotient. We are looking for this quotient. I hope you are following me so far. This is not that hard. It's just, we need to be very careful. So, we've shown how to do this division. I'll go a little fast here, but I will be putting the link in the description below where I have shown how to do this on a previous video. So, what do I need to multiply this in order to get this? And the answer is minus x squared. Minus x squared times 6 is minus x on the third power, so I go down here and I put the exact opposite. Minus 2 times minus x squared is plus 2x squared, so is plus 2x squared, so I go over here and I put the exact opposite, minus 2x squared. Again, I'm telling you that I'm doing a little fast because I've already shown this on a previous video. If you are not familiar with this, I'll put the description of the video, I'll put the link of the video in the description below. So, what do we have next? Minus 6 on the third power plus 6 on the third power is 0. 9x squared minus 2x squared is 7x squared. 7x squared minus 26x plus 24. And now, what do I need to multiply x with so to get 7x squared? And the answer is, can you find it? Plus 7x. 7x times x is 7x squared, so I put down here the exact opposite, minus 7x squared. And then this one times this one is minus 14x. So down here I go and put the exact opposite, that's plus 14x. If you get used to it, it will be very fast. Believe me in that. You just need to practice a little bit. At some point I will post a video with exercises for you to do without the solutions. And I may put the solutions on a different video. So, this and this is 0. Minus 26x plus 14x, how much is it? 26 minus 14 is 12, minus 12. Minus 12x plus 24. So, I believe that the last question is this. What do I need to multiply this with in order to get this? and the answer is minus 12. Minus 12 times x is minus 12x, so I'll go down here and I will put the exact opposite. Minus 2 times minus 12 is plus 24, so I go down here and I put the exact opposite. And as you've seen, we found 0, which is what we expected from the beginning, so we are correct. So, why did we do all of this? We did all of this because using the Euclidean equation, the Euclidean division algorithm, excuse me, we now know, what do we know? That we know that minus x on the third power plus 9 times x squared minus 26x plus 24 equals to x minus 2 times minus x squared plus 7x minus 12 plus 0, which is this one is equal to this one times this one plus this one. So we are almost done, because what we need down here is this. We only need this. Plus 0 doesn't matter, so we will not be picking this. So we got minus x on the third power plus 9x squared minus 26 times x plus 24, which is f of x, is equals to x minus 2 times minus x squared plus 7x minus 12. And this one we need it to be 0. Actually, let me do something different. Let me pick this and swap pages and put it down here. So let's finish this. What we care about here is this one. From here we can say that either he minus 2 equals to 0, which gives us the first solution or the first root of the equation f of x equals to 0, which is x equals to 2, which we have already found, and minus x squared plus 7 times x minus 12 equals 0. Here I've already shown this on a previous video. I'll put the link on the description below for the theory behind that. I'll do it a little fast here. So a is minus 1, b is 7, c equals minus 12, the discriminant delta is equal to 1. Again, I'm telling you that I'm doing this a little fast so that the video doesn't get long. I have already explained this, and as I've already said, I'll put the link of the video I'm explaining this on the description below. So x 1, 2 equals to minus b plus minus square root of the discriminant delta divided by 2 times a, which is minus 7 plus minus 1 divided by minus 2, which equals to minus 7 plus 1 is minus 6 divided by minus 2, minus 6 divided by minus 2, which is 3. Minus 7 minus 1 is minus 8 divided by minus 2 equals 4. So the roots are, the solutions are x equals 2, x equals 3, and x equals 4. And that was it. As always, if you found the video helpful, please consider subscribing, like, leave a comment with what you would like to see in a future video. And until the next one, see ya!